Differential and integral operations 9. Use an appropriate vector theorem to evaluate the closed contour integral dr dot v, where c is any closed path and v vector v is 2y squared minus 3x squared y parentheses ex hat plus 4xy minus x cubed parentheses ey hat. The appropriate vector theorem we can use is the Stokes theorem, which states that the surface integral d sigma dot product with curl of vector v is the closed path integral dr dot v. So this is known as Stokes theorem. To use this theorem, now we need the curl of vector v. So let's evaluate the curl of v using the determinant. Curl of v is equal to ex hat del x component 2y squared minus 3x squared y. Then we have ey hat del y component 4xy minus x cubed. And then we have ez hat del z 0 because there is no z component for this vector. And we're going to take this with respect to the first row. Okay, so for the ex hat component, del y of 0 is 0, del z of this quantity is 0, so therefore no contribution from ex hat. So we have 0 ex hat. For minus ey hat, we have del x 0 minus del z of this, which is also 0, also 0 contribution from ey hat. And now for the z component, ez hat, we have del x of this. So first we have del x of 4xy minus y cube, and then we're taking minus the y derivative minus del y, the x component 2y squared minus 3x squared y in ez hat direction. Okay, so evaluating this derivative here, we're going to obtain 4y for the x derivative. So we will have 4y for the x derivative here. This is del 4xy minus x cube, so not y cube. This is x cube. So we will have 4y minus 3x squared, and then here we will have minus 4y, and then we will have plus 3x squared. So we obtain for curl of v 4y minus 3x squared minus 4y plus 3x squared in ez hat direction, which is 0. So we can conclude that the surface integral d sigma dot product with curl v, which is the closed path integral dr dot v, according to Stokes theorem, must be 0 because the curl is 0. So here C is any closed path and finally, because the curl of this vector is 0, this implies that the vector v is derivable from a scalar potential as minus gradient of phi, which is to say v is a conservative vector field. So remember that curl of a gradient is 0. So if we go back to our identities that we have proven before, we have curl of a gradient equals to 0. So if the curl of the vector is 0, then it must be possible to write this vector as the gradient of a scalar function or minus the gradient of a scalar function. Therefore, V becomes a conservative field. So in order to evaluate this closed path integral dr dot v, we use Stokes' theorem, which is stating that the surface integral d sigma dot curl v is the closed path integral c dr dot v, where c is the path that is surrounding this surface. It's at the boundary of the surface. And curl v we can evaluate using the determinant. For ex hat, we have del del y of 0 with 0, del del z of this, there is no z component here, is 0. No contribution from ex hat. For ey hat, we have del del x0 and also no z component here, also 0 contribution. For ez hat, we have del del x of 4xy minus x cubed minus del del y of 2y squared minus 3x squared y in plus ez hat direction. And this gives us 4y minus 3x squared. So this was 4xy minus x cubed, to make it clear. And for the y derivative, we obtain 4y minus 3x squared with a minus sign. This becomes minus 4y plus 3x squared. They all cancel out, giving us 0. So curl of vector v is 0. Therefore, this integral is 0 according to Stokes' theorem. And because the curl of this vector is 0, it's derivable from a scalar potential, making v a conservative vector field.